Hello everyone. We are Group J11 from Division J of Vishwakarma Institute of Technology. We are a group of 6 members: Lakshmi, Kritika, Krish, Ayusha, Sai, and myself, Ashutosh. We will be explaining instruction cycles. Let us see what is instruction cycle. Instruction cycle: a program consisting of a memory unit of a computer which includes series of instructions. The program is implemented on computer by going through a cycle for each instruction. For example, in similar CPUs, the instruction cycle is executed sequentially, and each instruction is being processed before the next one is started. In basic computer, instruction cycle consists of following phases. The first phase is to fetch the instructions from memory. Second is to decode the instruction. Third is to read the effective address from the memory. And fourth is to execute the instruction. Ayusha will explain the role of components of instruction cycle.
My name is Ayusha Shirsakar, roll number 62. So let us discuss the components that are used in the instruction cycle. The first one is program counter, known as PC. Then there's memory address register, known as MER, memory data register, MDR, instruction register, IR, the control unit, and the arithmetic logic unit. So the program counter is a special register that holds the memory address of the next instruction to be executed. During the fetch state of the instruction cycle, the address stored in the program counter is copied into the memory address register, which is the MER, and then the program counter is incremented in order to point to the memory address of the next instruction to be executed. The CPU then takes the instruction at the memory address described by the MER, which is the memory address register, and copies it into the memory data register, which is called the MDR. So the MDR also acts as a two-way register because it holds the data fetched from the memory and also the data waiting to be stored in the memory. It is also known as a memory buffer register, MBR, because of this. So the instruction in the MDR is copied into the current instruction register, which is also known as just instruction register. So this current instruction register acts as a temporary holding ground for the instruction that has been fetched from the memory.
I'm Sai Shivsagar, roll number 64, J11. So we were studying components of instruction cycle. So now we have covered first four components. The next one is control unit. So during the decode state, the control unit will decode the instruction in the CIR. It sends signals to other components such as ALU and FPU. So ALU, arithmetic logic unit, performs logic operations such as and or not, binary shifts, and also operations like addition, subtraction, etc. Then FPU, that is floating point unit. Now, as the name suggests, it is required floating point operations.
So now let's talk about the stages of instruction cycle. Instruction cycle consists of 4 stages, that is fetch instruction, decode instruction, read address from memory, and execute instruction. So first, we are going to talk about the instruction fetching. So here, the CPU sends the content of PC program counter to MER. MER is here the memory address register and sends the read command on control bus. CPU copies these read data from MER to MDR, and in just fraction of seconds, this data copied from MDR to IR. IR is here the instructions register. So here is the graphical simulation which says CPU copies the data counter from PC to MER through the address bus and reads the data. These data is then stored in MBR, and after that, it gets stored in instruction cycle. So next, let's talk about the instruction decoding, which is called the decode stage. So here, the decoding progress or process allows the CPU to determine what instruction is to be performed so that the CPU can tell how many operands it needs to fetch in order to perform the instruction. The opcode fetched from the memory is decoded for the next step and moved to the appropriate register. Here, opcode is the instruction that is executed by CPU.
So my name is Chris, roll number 61. So after the decode stage, there are two types of instruction which is to be executed, memory and register instruction. So in case of a memory instruction, the execution phase will be during the next clock pulse. So there are two types of memory instruction, one which has direct address, other one which has indirect address. So in case of an indirect address, the effective address will be read from the main memory. And in case of a direct address, nothing is done during this clock pulse. So the execution phase will be done during the next clock pulse. In case of register instruction, the operation is performed during the same clock pulse within which the data was fetched and data was decoded. So now this is the fourth stage of instruction cycle, instruction execution. So this decoded data is now then passed through a sequence of control signals to the CPU. This CPU now sends this data to the ALU to perform mathematical and logical functions. So this data is after the performing of ALU is now written back to the register. The program counter where the data was stored initially will be now be ready to fetch the new data for the next instruction cycle.
Myself, Lakshmi Goyal, roll number 59. So basically, instruction cycle has four phases. Specific instructions and decoding instructions. And both execute instructions. For the result, produces is done by the memory. And the result is sent back to the memory through data bus.